That is not decoration. The gold at the tip, the copper surface, the metal rod running from that point down through the entire building into bedrock 40 feet below street level. An electrical engineer looking at this structure sees something completely different from what a historian sees. A historian sees a beautiful 19th century civic building. An electrical engineer sees a collector, a conductor, a system. And when you map every building like this, every courthouse, every government hall, every civic structure built between 1850 and 1910, the same system appears, on every continent, built simultaneously, according to specifications so identical they could have come from a single source. After 1910 it stops, the construction ceases, the metal elements are removed, the engineering specifications vanish from the journals, and the buildings are quietly redefined as decorative civic architecture. Tonight, I'm going to show you what these buildings were actually built to do. And at the end of this investigation, I will show you the diagram they removed from the engineering journals after 1910, the one that shows exactly what these domes were designed to collect. Stay until the end, because once you see that diagram, these buildings will never look the same again. Let me walk you through this building the way an electrical engineer would. The dome, copper, the second best conductor of electricity on Earth after silver, not a decorative cap, a massive conductive surface positioned at the highest point of the structure. The patina that forms over decades copper oxide actually improves certain conductive properties over time. And at the apex, gold, the one metal that does not oxidize, that conducts indefinitely, placed at the exact point where a modern building would position a lightning rod. The spires, metal rods extending from the corners and the central peak, officially called finials, decorative elements. But examine their construction. Solid metal cores running deep into the structure itself, connected to metal frameworks that web through the entire building. Positioned at cardinal points north, south, east, west with geometric precision. These are not decorations, they are antennas, collectors, positioned to receive energy from a specific direction and channel it downward through the building. The foundations. Every one of these buildings has foundations that descend far deeper than structural support requires. A courthouse in Indiana, 40 feet into bedrock. A government hall in Melbourne, the same. A civic building in Budapest, identical depth. Structural engineering does not require foundations at that depth for buildings of this size. There is only one reason to extend a foundation that deep, through specific layers of rock and down to the water table. To complete a circuit, dome to spire, spire to metal framework, framework through the walls, through the foundation, through bedrock to water, sky to ground. One continuous conductive pathway, engineered with a precision that the official history of these buildings completely ignores. But one building could be coincidence. This cannot. St. Petersburg, Melbourne, Buenos Aires, San Francisco, Budapest, Kolkata, the same dome proportions, the same metal compositions, the same foundation depths, the same geometric ratios between spire height and base width, the same conductive pathways running through structures built on opposite sides of the planet by architects who, according to official history, had no contact with each other. Official history calls this the Beaux-Arts movement, an architectural fashion that spread globally in the second half of the 19th century. But fashion does not dictate engineering specifications. Fashion does not require specific metal alloys. Fashion does not demand that every building's foundation reach the same depth regardless of local soil conditions. Fashion does not produce identical geometric ratios accurate to fractions of a degree across 6 continents. A system does that. A coordinated, engineered global system built according to a single set of specifications, distributed to builders on every continent simultaneously. And the stones chosen for these buildings are not random either. Limestone containing calcite, a piezoelectric material that generates electrical charge under mechanical pressure. Granite containing quartz crystals that store and release energy. The materials are not aesthetic choices. They are components. Capacitors. Storage systems integrated into the walls themselves. Map the location of these buildings across any major city, and the pattern becomes impossible to ignore. They are positioned at specific intervals. oriented to precise cardinal directions, sited at calculated distances from water sources, not clustered randomly the way civic buildings would be if their placement were driven by convenience or politics, positioned like nodes in a network. After 1910, it stops, not gradually, not due to changing tastes. Abruptly, the construction of these buildings ceases. The engineering specifications disappear from architectural journals. And then the demolitions begin, but not random demolitions, targeted ones. The San Francisco City Hall original copper dome, removed in 1917, replaced with a steel frame and concrete shell. Dozens of government buildings across America, metal spires removed and labelled as unnecessary or dangerous. European structures stripped of conductive elements during restoration projects that destroyed more than they preserved. The official explanations: safety concerns, changing fashions, modernization, but the pattern of what was removed tells a different story. The demolitions targeted specific elements, always the same elements: the copper domes, the metal spires, the deep foundation connections, the conductive pathways through the walls, and the timing. It coincides exactly with the establishment of centralized electrical power grids. With the formation of power companies, with the transition to wired electrical distribution that could be owned, metered, and sold, what if these buildings were not demolished because they were obsolete? What if they were demolished because they still worked? The diagram I promised you at the beginning of this investigation was published once, in a German engineering journal in 1908, 2 years before the construction of these buildings stopped, 2 years before the specifications began disappearing from the professional literature. It shows a cross-section of a domed civic structure. Every conductive element is mapped. The dome surface marked as primary atmospheric collector. The spires marked as directional receivers oriented to the ionosphere. The metal framework through the walls marked as internal distribution. The deep foundation marked as earth-ground connection, completing the circuit. At the top of the diagram, in the original German, a single label for the entire system: Free Energy Verteilung System, published in 1908, describing buildings that already existed on every continent, and then gone. The journal issue containing this diagram does not appear in any indexed archive. It exists in one private collection, photographed once, never officially acknowledged. These buildings are still standing. The copper is still there. The foundations still reach the water table. The geometry is still precise. We pass them every day. We call them beautiful. We call them historic. We take photographs in front of them. We were never taught to ask what they were built to do. Now you know to ask.